Join the conversation.
Join the conversation.
You're with Cape Talk.
Now let's go to the Naked Scientist, and remember your questions via WhatsApp on 072-567-1567. You can drop a voice note or a text note. Better still, you want to beat the queue. Your calls on 021-446-0567. Welcome, Dr. Chris Smith, lecturer at the University of Cambridge. We'll take our seats in class, and he'll guide you through the answers to the questions that keep you up at night. Welcome, Dr. Smith. It's great to have you back.
Morning, Clarence. Do you know, I've been doing my homework. You're talking about taking your seat in the classroom. Last week, we had a really interesting question about statins, that are the cholesterol-lowering drugs, and vitamin D. And I said, well, I've never been asked that. What a fascinating question. And I speculated that there wouldn't be an effect, but I did say I will do my homework. I've gone and done some homework. There are not huge numbers of trials on this, but there are a number, and those seem to suggest that on the whole statins should not affect your level of vitamin D. Some do put the level up a bit, some can put the level down a bit, but they don't ultimately affect the ability to make vitamin D. And the rationale for asking the question, the lady who called in said, well, if statins lower cholesterol and vitamin D is made from cholesterol, do statins put your vitamin D level down? Now, actually, vitamin D is made from 7-dehydrocholesterol, which is a side product of the process that is going to make cholesterol, and it's therefore upstream of the production of the cholesterol you are impacting on with statins. So therefore, that's why statins, probably through other mechanisms, might tweak the levels of vitamin D a bit, but they won't affect your ability to make it to start with, and that's why there's not a massive great reduction in vitamin D production when you start taking statins. So thanks for a really interesting question, which I wouldn't otherwise have even thought about, and I've enjoyed doing a bit of research around it.
And thanks for doing your homework, teacher. Now, let's go to the voice notes, Joe. Let's play one.
Good morning, Clarence and your team there, Flora Sifa Booster. Clarence, please ask Dr. Smith there. Good morning, Dr. Smith. The phenomenon of a leap year. Who came up and who invented this silly thing? It's unfair to people who was born on this day, who needs to wait for a birthday every 4th year. I know someone, and he told me once that he's celebrating his birthday at the beginning of a year, because no point celebrating it on the 28th of February or the 1st of March. And why don't we take a day from January and then just add it to February, and then we can have a full 29 days, and we can negotiate with the guys that was born on the 31st of January that they can celebrate their birthdays together. Can we not change it? Because this thing is human-made. So, we can change it and just have 29 days in February, 30 days in January. Have a good show. Bye.
I think the question is, why can't it just be calibrated in the manner that it should be?
Yeah. Well, I think there is an advantage to being born on the 29th of February, which is that you die aged 100 and someone says, you don't look a day over 25. But the reason we do this at all is because the reason we have days is because the Earth is spinning on its axis, and it takes 24 hours a day to go completely round its axis and get back to where it started. It also takes 365.25 of those days to go right around the sun, in other words, to make a year. So because it doesn't have a complete day number in its orbit, we end up with a discrepancy of a quarter of a day. And if this were allowed to add up, eventually we'd be celebrating Christmas in the middle of summer, and we'd be celebrating, in some parts of the world, and we'd be celebrating our winter skiing holiday in the summer as well, as it were, because the days would slip, and by the time you'd gone a few years round the calendar, all of the seasons, when spring should be, autumn, winter, would be completely out of whack. And this is because it takes 365.25, in other words, 365 and a quarter days for the Earth to complete one lap of our solar system, otherwise known as a year. So, to fix that, we add a day to a month every 4 years, that's February in this case, and that gives us a correction mechanism so that we stay on track with our seasons, lining up with where the Earth is in relation to the Sun, so that we stay in the right position on our calendars. When did this first happen? Well, I think the Romans were the first to start adding days to the calendar. I think around about something like 50 BC, 49 BC, sometime around then. And I think it then got fixed in February in about the 15th century. But if any historians listening know better, please do let me know. But it's not a new phenomenon, basically. We've been doing this for hundreds to thousands of years in order to correct the fact that the Earth inconveniently doesn't have a complete number of days in its orbit round the sun.
Then a message in to the amazing doctor. Please help me understand which came first, the chicken or the egg? I stay awake at night thinking about this.
Hi, Ishmael. I'm going to go with egg, to be perfectly frank. I mean, we know chickens are a modern phenomenon, but chickens are descendants of dinosaurs. They're living dinosaurs to many biologists' minds. And so, therefore, if a chicken comes downstream of a dinosaur and dinosaurs laid eggs, therefore the egg must come before the chicken, because dinosaurs were reptiles, they laid eggs, and this preceded the way that we have children, which is to have our eggs inside us and have a uterus and then breastfeed with mammary glands and so on, by giving birth to a much less developed young, which we have to nurture. So by definition, because chickens are descended from dinosaurs and dinosaurs had eggs, eggs must come before chickens.
There we go. Simple answer, Ishmael. Let's go to another voice note. Joe?
Hi, Dr. Chris. This is Logan from Edenville again. I just have a question. How close or similar is the moon Titan of Saturn to Earth? And how likely or how possible would it be for us to actually live there?
You wouldn't want to live there. A friend of mine called John Zarnecki, I first met him back in 1997 because I was a medical student at the time, and he came to Cambridge University where I was a student, and he gave a talk. And this guy said, in 2004, a probe I'm about to launch is going to arrive at Saturn, and it's going to visit Titan with a Huygens lander, which is a special part of the probe I've built, which is going to land on that moon. And I was just blown away to think that you would design something that would then spend 7 or 8 years travelling across space to go millions of kilometres to arrive at a remote world that no one had ever seen. We've seen it from far away, but no one's ever been there. And they were going to land this Huygens probe, or descend down through the atmosphere of Titan, and send back pictures and possibly some sound and other data. And I said, well, what conditions will the probe experience on its way down through Titan? Titan looks a sort of orangey colour because it has an incredibly dense atmosphere of not water like we do here on Earth, but hydrocarbons. It rains methane and ethane and propane and butane, I think, in smaller amounts in the atmosphere of Titan. It's minus 200 degrees C. And so the probe that they sent there did descend, it did lower itself on a parachute down through this very dense, very thick atmosphere, and they did get some pictures, but not for long, because it's so cold, it's almost impossible to make things work for a very long time. And when you get to the surface, it's a sort of slushy, hydrocarbon, icy surface. It's not a hospitable place, and I don't think under those conditions and those pressures you want to be there for very long. But there are other places around the Saturnian system that are very interesting, and Jupiter the same, because these are massive planets. They exert huge gravitational pulls on the moons that go around them. And some of those moons aren't awash with hydrocarbons, they actually have water. And we know that the neighbour to Titan is Enceladus. And Enceladus is being stretched and squeezed by the gravity of Saturn all the time. And this is having the effect of heating up the interior. And scientists on the Cassini mission noticed that there were these plumes coming out of the surface of Enceladus periodically, and when they flew Cassini through the plumes, they could use the instruments on the satellite and the probe to analyse what's in the plumes, and they discovered water and salt. And this led to the theory that inside Enceladus, and therefore probably also inside some of the moons of Jupiter, or at least one of them, there is a liquid ocean. And because those conditions are probably very similar to the conditions on the early Earth, with warm water, there's the possibility that the sorts of chemistries that got life going on Earth could be at play on these other moons, like Enceladus and like Europa around Jupiter. And therefore there are now missions going actively to look there to see if we can see any other hallmarks or signatures that might indicate that these could be hospitable and could therefore be home to alien life.
Hi, Clarence. Please ask Dr. Smith this one again. In hindsight, what really caused COVID? Really? Was it made in a laboratory or natural causes? Thank you, Sue.
Hi, Sue. Well, from the get go, I was actually quite open about my skepticism for a natural origin for COVID. I was quite strongly leaning towards this being not intentional, but an inadvertent release from a laboratory. We know, for example, that there were researchers at an institute called the Wuhan Institute of Virology in Wuhan, in China, who were working on coronaviruses. They were the foremost experts in the world. We know they were collecting samples of coronaviruses internationally, and they were bringing them back to that laboratory and working on them. We know that they collected historically samples of coronaviruses which were very, very similar to the SARS-CoV-2 virus that ultimately circulated and caused the COVID pandemic. We also know that they were working on gain-of-function mutation work in this laboratory. This is a perfectly legitimate thing for virologists to do, and it involves taking a virus and doing things to it artificially to manipulate it to explore how it might evolve, how it behaves in certain settings, in certain animals, in certain cell types, and how certain drugs or treatments might work, or how the immune system reacts to it. One of the projects they were doing was adding a certain component to these viruses to see how that might affect their ability to be propagated in the laboratory, their ability to infect certain animal types, and so on. And although they bid for funding from America for one of those projects and it was turned down, the mere fact they asked for funding to do that very work that then subsequently manifests as something that looks very like what they're proposing, the virus that caused COVID, that emerged months later. As one researcher who wrote a book on this called Alina Chan put it, if you see a grant application where someone says they're going to strap horns on horses and then months later you find unicorns running around, you do have to ask whether the two might be connected. And so I think that there is a smoking gun there, and this has not been helped by the fact that China have not been at all transparent. They have not supported international requests for more information. They have frustrated efforts to investigate. They have made certain strands of data disappear and obfuscated what happened. And right at the early days of the outbreak, they were not keen to share with the world what was really going on. And there's evidence that information flow was suppressed, certainly to start with. They were not transparent and not open. And this has raised people's concerns that if you've got nothing to hide, why do that? On the other hand, if you do think that there might be some kind of finger pointing going on or likely to happen, you might take steps to hide what has happened. So I think that there's very good grounds for doing a proper investigation, because look at the cost of all this, and there's quite good evidence that this might not have a completely natural origin, and therefore it warrants investigation. What we certainly shouldn't do is just assume, oh, this is a natural phenomenon, put it to one side and carry on, because that's how we get caught out a second time.
Dr. Smith, what would you consider the most fascinating phenomenon in the natural world that science is not yet able to explain?
I'm not an expert on physics, and so therefore I'm being slightly dodgy when I say I think Einstein's spooky action at a distance. Obviously, it wasn't him. He called it spooky action at a distance. But I think the whole question of entanglement and how that branch of physics and the quantum world operate, that's really mysterious. Let me explain. If I take two particles of light, which I have entangled, so I've created some light and I've given them a shared relationship, I've entangled them, they're bound together in some way, and I take one to one side of the universe and one to the other, and I do one thing to one of them, the other one instantly knows, in inverted commas, I've done something to its partner, and it changes too. Now, how on earth that works, I don't know, but if we can solve that one, we understand an enormous amount more about the way that the universe works. So the quantum world, I think, remains the one which has the most interesting things to reveal to us and why things work the way they do. And that will be the most exciting. That and particle physics, because understanding the fabric of the universe and dark matter and dark energy and why the universe is made of what it's made of and the way it's growing and evolving, this is all bound up in much of the same stuff. And so I think in the coming years, when we get to grips with what dark matter is and ultimately what dark energy is, what's driving the expansion of the universe, those are going to be some really exciting things because they will tell us an enormous amount about our place in this cosmic neighborhood.
Let's go to Zuki. Zuki from Big Bay. She's on the line. Welcome, Zuki.
Hi, Clarence. Hi, Dr. Chris.
Morning,
So
Suki.
I'm not sure if you've heard of what they call. I don't know if you've heard about what they call the triangle effect on the face. So I've seen a lot of people say that you shouldn't extract or pop pimples in the area, like the triangular area from your nose bridge down your nasolabial folds and across your chin, because that can cause death. So is this true? How prevalent is it? Should we be worried? And if it is true, then shouldn't we also be concerned about cold sores?
Hi, Zuki. Yes, you're referring to what we dub the danger area of the face. So if you were to run your finger up your top lip from the middle, round the outside of your nostril, and then onto that patch of cheek, which is to the side of your nostril, above the lip where you'd sort of have a line below the edge of your nostril and below your lower eyelid, that triangle is the danger area. The reason it's called the danger area is because there are veins that drain that part of the skin which anastomose or couple up with veins that drain into a pool of blood that sits inside the skull called your cavernous sinus. The brain has large blood vessels in it called sinuses that drain blood from the brain surface and then put them back into the peripheral circulation. And this particular one, because it has a connection to not just the brain but to the outside world, there is the possibility, if you drive infection into that set of blood vessels, they could allow infection to transmit through those connections to that sinus inside and then cause a thrombosis or a blood clot to form there and infection to flourish there, and that could be really nasty. And that does happen periodically, so people are always urged, if you get nice big pimples and things, don't squeeze them really hard on that patch of your face, because there is this small chance that you could drive the bacteria deeper into the tissue, through the dermis, and then into these blood vessels, and they could infect your sinus system around the brain and cause effectively a meningitis from there. The problem with cold sores is slightly different, because cold sores are caused not by a bacterial infection but by a viral infection. This is the herpes simplex virus. It comes out of underlying nerves which are innervating or supplying the overlying skin. The virus particles bud off from the nerve endings and they infect the overlying skin. And those skin cells then become infected and they become virus factories producing a sore patch which is fully infectious, and you can then pass that on to the next person. Because the blood of a person who's got herpes simplex, because to have a cold sore reactivating in that way, you must have been prior infected with herpes. You've got antibodies in your blood which recognise and will neutralise that virus. So if it goes deeper into your bloodstream, it's much harder for the virus to then not be mopped up by antibodies and stopped than if it's just budding off and hitting overlying skin cells where the antibodies which are in the blood can't get to quite so easily. So it's much less of a threat from a virus point of view, and bacteria and possibly fungi are a much bigger threat for the danger area of your face.
Thank you, Zuki, for that question. Chris in Paarl is on the line. Chris, go ahead.
Yes, good morning. I would like the naked scientist to please explain to me how wireless charging works, please.
Well, in exactly the same way that a transformer has a coil of wire supplied by mains electricity, and this is an AC current cycle, so it's electricity which is going backwards and forwards in the wire. This is creating a changing electrical field around the wire. And if you have a changing electrical field in and around a wire, you will get a changing magnetic field. So a coil of wire with AC going through it is going to make a changing magnetic field. If you bring another coil close to that first coil, then the coil that is your secondary coil sees this changing magnetic field. And because there are particles in the coil, electrons, negative charges, which respond to a changing magnetic field, they will start to move in sympathy with the changing magnetic field. And this will drive a current to flow in the secondary coil. When we have a transformer, we put the two coils around an iron core, and this is because the iron picks up and is susceptible to the magnetic field, and it guides the magnetic flux very efficiently into the secondary coil, so you have minimal loss of energy. But you don't have to have that iron core there. If you have the coil, which is your supply coil, in one thing, and then you bring your other coil in another device just close to it, there'll be some losses, but it's still seeing a changing magnetic field because the magnetic field will go through the case of the object, and it will induce a current to flow in that secondary coil. And by choosing how many windings, how many wire windings there are in that secondary coil, you can change or you can set what voltage you want it to run at, and it will pick up those magnetic flux lines. It will induce a current to flow in that secondary winding at the voltage dictated by the number of windings, and that can then be put through a rectifier, which will correct it to DC, and that's then smoothed out and put into the battery to charge your device.
And that is absolutely fascinating. I think the one thing about The Naked Scientist is that I now know that there are questions that I didn't even realize I needed answered. Thank you, Dr. Chris Smith. We're going to have to wrap it there. And maybe just with this little anecdote that came after your explanation of leap year. Interesting explanation of a leap year. I live in retirement apartments, and last week we celebrated a fellow resident's 23rd birthday. She looked lovely for her age, as in reality she is 92. Take care, Dr. Chris Smith.
Have a good one. Thanks, Clarence. Thanks, everyone. See you next week.